Welcome to the Miss Foreman's Fabulous Fraction Show, starring Miss Foreman. That was funny. Alright, so I'm going to go ahead and get started, and then if some friends join in, they can just follow along as we're going. I'm going to start off by looking at number 2, in which it shows 2/5 times 5/6. Now, our focus has not been on this model. We are right now, our focus for our target is a rectangular area model, so I'm just going to ignore that, and I'm going to recreate it with a rectangular area model. Hey, welcome. So glad you could tune in. Hopefully this helps. And when I create this, I'm going to label one side 2/5 and one side 5/6. And we said it really doesn't matter what side I label, so 5/6. Wait, I missed the filter. And then 2/5. So the reality is that this one I'm going to be drawing my lines going down, and this one I'm going to be drawing my lines going across. The denominator tells you how many equal shares I'm going to have. So here I'm going to have 6 equal shares. And in order to draw 6 equal shares, I'm going to draw how many lines? Right, 5 lines. So I would draw 1 here, 2 on this side, and then 2 on this side. You know, I do the dots first and then try to figure it out. Because I try to make them look as even as possible. I know I'm not going to spend forever on it, but I try to make them look at least as even as possible so they don't look like a hot mess. Okay, so here I've divided into 6. 1, 2, 3, 4, 5, 6. And I need to represent how many of those 6 shaded. And that would be 5. Oh, good. I'm so glad you did so well with Mr. Redding's homework. 1, 2, 3, 4, 5. So that's 5, 6. Hey, Horror Universe. Nicholas, welcome. Horror Universe. All right, I'm such a dork. All right, and then this one, I'm going to do 2/5. So again, this tells me how many equal shares I'm going to have. And in this case, I'm going to have 5 equal shares and 1 less line. So 4 lines to show 5 equal shares. So again, I kind of make my lines light first just so I can visually see it. All right, so 1 line, 2 lines. Oh, I'm so glad I'm not a dork. Well, I'm a good dork, though. I'm a math dork. I don't know. Okay. Well, anyways, thank you for making me feel better. I'm not a dork anymore. 1, 2, 3, 4, 5. So I've divided it into fifths. And now, again, I'm going to shade in this many fifths. So 2/5. And again, this one is going to be going horizontally. So there's 1/5, and there is 2/5. And so what we discussed is once we've shaded it, we can now find our answer by finding the number of overlapping parts. And you know I chose pink and purple, by the way, because you shout me out on your channel. You are awesome, Nick. I love you. Anyways, I chose pink and purple because they're my signature colors. So yeah, they're like my favorite. So this is the part that overlaps. And I can see it's 2 down by 1, 2, 3, 4, 5 across. So if you were to count 2 times 5, there's 10 that are shaded with both that have the overlapping. So 10. And then how many total? There's 5 going down, and there's 6 going across. If you were to count every single one, there would be 30. And again, I told you could check it. Multiply your numerator times your numerator is 10. Denominator times your denominator is 30. However, we're not going to leave it this way. We want to figure out what do we know about 10/30ths? What do I know about 10/30ths? Hopefully you would recognize even from your 4th grade, really basic standard, that you can get rid of both of those zeros. In other words, divide both of them by 10. 10/30ths is equal to 1/3. Boom! Drop the mic, dudes. All right, so let's look at the next one, number 4. Moving on. Hey, where'd that? Oh, that's a pen shadow. That was super weird for me. All right, anywho. Again, I'm going to draw a rectangular model to help me solve. So right below that, draw my little rectangle. love you today, Nick. I'm telling you, you're my favorite. Don't tell me that. Don't repeat that. What do you mean that's on camera? Oh, I don't know what you're talking about. All right, anyways. So 3/4 times 1/3. Again, it doesn't matter which you label on which of your axis. However, I tend to label the one with the bigger denominator on my long side just because I have more space then to draw my lines. So I'm going to label this one as 3/4 and this one is 1/3. But again, it really doesn't matter how you label it because we can change the order of our factors. But anywho, I'm going to divide this into 3/4. So I want you to think, how would I represent 3/4? All right, I would take this whole model and I would divide it into 4 equal parts by drawing a total of 3 lines. 4 parts would be 3 lines. So 1 in the middle and then 2 on each side. Boom. Very nice, very nice. Good answers. So I'm going to shade 3 of them with my signature purple. 2, 3, boom, 3/4. Ta-da! And now I'm going to do the same thing with 1/3. I need to now do the same thing. This one was going down, I was going vertically. This one, I'm going to draw my lines this time going horizontally. Wow, that was sort of scary. I'm going to draw them going horizontally. Scary movie. I'm going to draw them going scary. Okay, so I need to divide it into thirds. How many lines would I draw to divide it into thirds? Right, I'm going to draw 2 very scary lines. 1, 2. Oh, this math is so scary. Oh my gosh, a horror film. And then I'm going to shade 1/3. So 1 out of the 3. Boom, boom, boom. And now I'm just going to, again, count my overlapping part. If I have 3/4 and I want to find 1/3 of my 3/4, my answer would be 1, 2, 3 out of a total of 3 down times 4 across. 3 times 4 is 12. And again, you can check your work. Numerator times your numerator. 3 times 1 is 3. Denominator times your denominator. 4 times 3 is 12. And then all you have to do is think, what is it that I know about 3/12? What is it that I know about 3/12? Well, I do know that they could be both be multiplied by 2 and get 6/24, but that's actually not where I'm going with that. Let's see, what could they both be divided by? Well, let's look at 3. 3 only has the factors of 1 in itself, so could 12 be divided by 3? And the answer is yes. Both of these can be divided by 3. They share that common factor pair of 3. So 3 divided by 3 is 1, and 12 divided by 3 is 4. So both of these are acceptable answers because they are equivalent, but we want to be fluid with our fractions and practice getting it down into that lowest common term, that smallest equivalent fraction. Just as we did there. All right, so let's look at number 6 again. We're going to go ahead and draw. Listen, out of 3 teachers, you've got like 2 because one doesn't even, you don't even have like that one. We're not going to talk about that. Never mind. We're not going to talk about homeroom. Sorry. I'm really sorry. All right. Yeah, that's not a good situation. All right. 3/5 times 3/5. Well, that's lucky because it really doesn't matter how you label it because they're both 3/5. So here, I'm going to divide it into fifths, which means how many lines am I going to draw? Right, I'm going to draw 4 lines. So again, I just like to do my lines first to make sure that, the spacing is kind of sometimes off, like there. That spacing wasn't great. That's funny. I'm not going to, that's not funny. That's mean. Yes, it is funny. No. Okay, shut up, Miss Foreman. All right, so I have it divided into fifths. 1, 2, 3, 4, 5. And I need to represent how many fifths? Whoa, sorry about that. I need to represent 3/5. So 1, 2, 3. Boom. Oh, wait. Boom. 3/5. Okay. And then I'm going to take that 3/5 and I'm going to do the same thing. It's like deja vu. I'm going to take it again, and I need to draw 4 lines to show 5 parts, and these are going to be 4 horizontal lines. These ones were verticals because, again, when we do an area model, we're cross multiplying. So 4 lines. I'll just do my quick little lines first to kind of guesstimate. All right, so let's check it out. 1, 2, 3, 4, 5. Boom, got 5. All right, and again, I'm going to do the 3. So I have 3 overlapping parts. Now, here's what I'm going to do. I'm stopping right there. Why is it that you think I decided to stop right there instead of going all the way across? I want you to think about that for a moment. I actually decided to stop here instead of going all the way across because these other parts that are not overlapping, we don't use them. So I already know that part's not going to count. I only need the overlapping parts, so I saved my beautiful purple ink and stopped right there, and I didn't draw all the way across. So now look, how many overlapping parts do we have? 3 by 3, 3 times 3, there's 9 there. And again, if you were to count them, you would see 9. And then out of a total of 5 down by 5 across, 25. So again, if you counted 5, 10, 15, 20, 25, boom. You get 9 25ths. 3 times 3 is 9. 5 times 5 is 25. Check. Cha-ching. It works. Ta-da. Now I just want you to think, can I turn that into a smaller equivalent expression? So first look at the 9. What are your factors of 9? Right, you have 9 and 1. We know that 25 cannot be divided by 1. I do like messing with the camera thing. It is so cool. I'm such a dork. That's why I got this iPhone 7. It's off the chain. I'm not buying the 10 because I'm too poor and I'm too cheap. So there's that. And then, okay, so anyways, this is 1 and 9. This 25 cannot be divided by 9. And our other factor pairs for 9 is 3 times 3. 25 cannot be divided by 3, so this is the only answer that you need is 9 25ths. Boom, done. Last question for the night. And then I retire Queen Math Teacher for the night. Yes! All right, so Marlon bought 7/8, and I'm just going to do cubes as we're going to save us all time. 7/8 pounds of turkey at the deli. She used 2/3 of it to make sandwiches for lunch. How much of the turkey did Marlon use for sandwiches? Okay, so what I do know is that originally she bought 7/8 of a pound. So if I wanted to represent that in a picture model, I could do 7/8. You did extra. You go, girl. You did extra. Oh my gosh. See, I need you. I need you in my room. I love it when people do extra. I love math. I would be the person to do extra. So 7/8 first is what I would represent because they bought not a full pound. If you envision this like as a full pound, they didn't buy the whole pound. They only bought 7/8 of it. So I would draw 7 lines. So this would be 3 on each side. 1, 2, 3. And I know that, Nick, you're going to get me my level 5, by the way, because you, are such a hard worker. Yep, I got to have my level 5s. I'm going to push you, and I'm going to make you crazy, but you're going to be at level 5. It's going to happen. All right, so anyways, this whole thing is a whole pound, so that's 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, and 7/8. So that's how much she bought. Now it says she uses 2/3 of it. Oh my gosh, yes, I do remember you coming with me last year. I actually wanted you then, just saying. I used to always brag about you. I was like, oh my God, that girl is so sweet. You were so quiet when you came with me. It's such a good... versus the other friends who were with us, not so much. But you were really good in the lab. Did I bring peppermints when you came in the lab? Because I gave out so many peppermints last year. It was ridiculous. All right, 2/3 ice shaded. And my question to you, I know that we are all pretty good at this point about counting our overlapping parts. I have 2 down times 7 across. There's 14. And out of my total amount of parts, there's 3 down times 8 across, 24. Can these both be divided by a smaller equivalent fraction? See, I totally remember you. You were really good. You kind of sat off in that corner over there by somebody who, never mind, I'm not going to say their name. But I remember who you sat by. They were a little bit on the loud side. Those could both be divided by 2, and you would get 7 12s. Cha-ching! But what I was going to ask is, there is a keyword, if anybody recognizes it, and the keyword is of. Of tells us to multiply, just like when we were doing our numerical expressions, when we would say, oh, like what is half of 10? We knew to multiply it, or to do the reciprocal, to divide by 2. So anywho, that is it. On this scary, awesome math night. Ooh, dream of purple and pink fractions. No, I'm just kidding. All right, if you guys have any questions, feel free to leave your comments. Feel free to hit me up. And other than that, have a beautiful pink and purple and pretty. Carla! Hey, girl, hey! Wait, no, I just ready. Okay, first of all, by the way, I just showered, so just forgive me, I look like garbage. Hey, girl, hey, Carla! Miss you! All right, so Carla, I'm going to tell you a story anyway, since you're on here. So Carla, this year we're doing the canned food drive, but this year's so awesome because we're only collecting like certain foods, and so we actually have like real Thanksgiving foods, which is super cool. We have tons and tons of stuffing and potatoes, and we've got marshmallows and every kind of thing that you would need to have like a real traditional Thanksgiving meal, and it's so cool. And we put together bags, Carla, bags. So we're giving families this year bags with the whole meal already in it, and even we had some people donate gift cards, so that's pretty cool. They're gonna get turkeys, so I'm so excited. I just had to tell you that. Anywho, that was like a side note. Yay! Oh my gosh, I'm such a dork. All right, anywho. All right, guys, I won't keep you up late. I know that you would have nothing that you'd rather do than draw fractions all night, but I'm gonna get ready for tomorrow. I'm excited for student-led conferences. I hope you guys have a parent or friend who cannot come, but otherwise you will have somebody come meet with you. Remember that you're allowed to dress up if you would like. Yeah, you can dress in your business best and look all impressive. Bye, Carla. See, I love it when my friend visits me. I love you, Carla. All right, guys, have a great night, and I will see you in the morning.